All right, so today I'm going to teach you a little bit about the law of sines, and Miss Bell from the other class across the hall has been gracious enough to come over here and listen to me.
Hi guys.
So I'm not sitting here talking to myself, because it is kind of crazy here. Sitting here talking to yourself and teaching to nobody. Okay, but here we go, law of sines, and I'm going to teach you how to find the area of a triangle. First I'm going to do it the long way, and then I'll show you a shortcut. Start off up here. I would want to sub right now. Go ahead and hit pause. And in your groups, go ahead and discuss what do you need in order to find the area of this triangle, ABC. Okay, so go ahead right now and hit pause and discuss that. All right, I guess you're back. Okay, and hopefully you talked about you needed the height. When you're talking about finding the area of a triangle, you're going to need base times height, divide by 2, and it looks like we're missing the height. I divided this up into 2 triangles. Okay, right over here I found the height of this triangle right here to be 9.19 using the right triangle, okay, that I had there in red. Okay, I then used my area formula, base times height, divide by 2. Okay, took that height of 9.19, times it by the base of 20, finally divided that by 2, and I got 91.925. Okay, remember this number right here, because I'm going to now show you the shortcut. Okay, like normal, okay, you're going to enjoy this because I'm not going to actually prove the formula. I'm just going to give it to you and then show you how it comes out to the same answer. Okay, that would be proved the same way that we did the other one right there. You're going to end up dropping a triangle down, okay, and you're going to use this area formula, okay, but instead of base and height, since we're given an angle right over here, I ended up using a sine rule that you can either write it as 1/2, because it's half base times height, times the A side. Remember, the A side is opposite of the A angle. The B side is opposite of the B angle. Okay, and the C side is the angle that we have been given. You have to be given, okay, in this case, a side, an angle, and a side, with the angle must be between the 2 sides in order to use this rule. And notice, I'm going to get exactly the same thing we came up with, 91.9253, I believe, on the last page right here. We got exactly the same thing. I used, for my B and my A, okay, I plugged in my B as 20, I plugged in A to be 12, times those together and multiplied it by sine of 50, and I got that answer. Okay, so go ahead and write down and make sure you wrote down, okay, this is the law, the sine area formula. And we will eventually learn one with cosine too, but right now we're going to talk about all law of sines and the sine area formula today. Okay, going on to our next formula. And again, I'm going to show you how I derived this law of sines. The law of sines is again going to come from 2 right triangles. Okay, I'm going to call side C as the side that is opposite of side C, A opposite of A, and B opposite of B. Okay, when I have all of that in there, I'm going to come up here and use, okay, the sine of angle A. Sine of angle A is going to be H over C. Using my other half of the triangle like I did in the area formula, I'm going to use it H over A. Okay, so I have 2 formulas that both equal H. Miss Bell, do you know what I'm going to do with these 2 formulas now?
Set them equal.
Oh yes, we have systems and equations. Miss Bell is on top of her game today. Okay, we're going to take this equation right here and we're going to substitute, that's systems and equations, so set them equal to by substituting them in, okay, to the other H. Okay, so we have, okay, right here, this right here is the law of sines, but they do us a favor, okay, in order to help you memorize this, and that is one thing we didn't go so good on the identity part of the test. We got to memorize formulas. So I am going to put the A's all on one side. This A cancels right here, and I have sine of angle A times side C over side A. This side I just have sine of the angle And then I'm going to finally divide this out. So we get the rule, sine of A over A equals the sine of C over sine C. Okay? Now, that's one version if I chose to use angle A and angle C. Okay, just to shorten this lesson down, go ahead and do make note that if I did angle B, I'm just going to use the side that's going to be opposite of it. And then I can either use the side C or I can use side A. It does not matter. Okay, these rules, okay, right here are going to work as well. Okay, I could just put this one down right here. It can be any ratio, okay, between the sine of the angle and the side that is opposite of that angle. Look pretty nice, don't they, Ms. Val?
It's the transitive property.
That is the transitive property. You are correct. All right, so how do we use these formulas? Okay, so here you go. Okay, the one thing you got to know is that in order, and this is the most important part of sine, law of sines, okay, and this is why I'm going to say I will always use the law of sines before that law of cosines, is because it is a heck of a lot faster. But there's one thing you've got to have. That is a ratio. You have to have a ratio between the angle and the side. Okay, once that is set, okay, you can automatically say, in this case right here, I'd have my sine of W over side W. That is going to be a given. Okay, so here's my first step that I have right here. Okay, is I have my set ratio right here, sine of 40 over 50. Okay, but what I'm going to have over here is the missing side is going to be my S side. I have this angle, sine of 32, okay, but I don't have the side that's opposite of it. Well, we do have a proportion. We cross-multiply on these proportions, which I did on this step. Okay, I came up with, okay, this part right here, the x times the sine of 40. I come up with 50 times the sine of 32. Okay, I have x is what I'm trying to solve for, so to get rid of this sine of 40, you could do the decimals for these and multiply them all out if you'd like. Okay, because of time and I didn't have my calculator handy, okay, I just said I'm going to divide both sides by the sine of 40, and I come up with the length of this side right here is 41.22. 41 and 2200ths. All right, if you have any questions, hit pause right now. Okay, you can ask the sub. Okay, ask if anybody else can help out, go ahead and do so. And we're going to go on and do another example here. All right. Go ahead and discuss in your tables right now. Can you use the law of sines first? If you look at this triangle right here, the one thing I would always look for first is can you use sine, cosine, or tangent? That has to be your first step. But as you look at this one, it's not a right triangle, so those methods can't be used. If you want to try to use the law of cosines, shoot, go ahead. And more power to you, but it doesn't look fun to me. Okay, the last option is can you use the law of sines? And Isabel, what did I say we had to have in order to use the law of sines?
A ratio.
We had to have a ratio. Man, she is good. All right, so I'm looking, and I'm looking, and I'm looking, and there's no ratio. Do we have to use the law of cosines on this spell? No.
Hope not.
She hopes not. Okay, we're missing one thing. Okay, if we would have this angle right here, we would have a ratio, and
Wait, you can find that angle.
okay, we can. Okay, so I'm going to take, okay, right up here and find that angle right there by adding 42. Okay, and okay, 36 together, I get, I hope, 60, 78, because that's what I did ahead of time. Subtract it from 180 degrees, and I got 102. So here is a ratio, okay, between 102, okay, and 12. Okay, I then do my cross product method. Right there, multiplying sine of 102 times AB, take the 36 times 12, okay, and I'm going to divide by 102. Okay, and again, I a lot of times do the decimals in there, but don't round if you do. Okay, just for time purposes here, I plug that all into my calculator, and I always round to the hundreds place, Don't round anything before that. And I got 7 and 21/100ths. All right, so again, you can hit pause, ask any questions here, okay, if you do have any questions. Okay, this is using what we call the law of sines. So you've had 2 formulas so far. Okay, one was the sine area formula, which was 1/2 AB sine of C. And the second formula, which is the law of sines. Okay, we are going to roll on here, and I am going to do this here. I'm running out of time this period, so I'm going to hit pause, and I'm going to come back here after I'm done teaching 7th hour. So I'll see you here in a bit. All right, so I'm back here. I had to wait till after 7th hour to finish my lesson here, so I know it was only a couple seconds for you. But this last case that I'm going to run through is what we call the ambiguous case for law of sines. And it is an ambiguous case, okay, when you're using the law of sines, but it's because you're going to be given an angle with a side and a side. So I know you've heard about the ASS rule before in geometry. Well, this rule again is going to cause some problems in pre-calc in how we go about using the law of sines. One way to avoid this ambiguous case is to use the law of cosines, which I will show you tomorrow, but I feel still the first thing I'm going to always check when I see a triangle is, first, is it a right triangle? Can I use sine, cosine, and tangent? And then second, can I use the law of sines? And just to refresh my memory here, okay, tell your neighbor next to you, how do you have to know whether or not you can use the law of sines or not? What do you need in order to use the law of sines? Okay, go ahead right now and tell your neighbor next to you. All right, hopefully you told them that what was needed was a ratio here. Okay, if we're trying to find angle C, okay, we can find, okay, angle C, because we do have a ratio here. Okay, this is, okay, using, okay, in a triangle, side-side angle, you can use the law of sines rule. And I have done that right here for you. Okay, I have set up using the law of sines. Okay, I did the sine of 20 over 4, and then I did the sine of angle C over 10. I cross-multiplied right here. Okay, once I'm done cross-multiplying, okay, I divided. That gives me my 10 sine of 20, and then I divided this side out right here by 4 on both sides, and I got 0.8550. Do the inverse sine on both sides, and I got 57 degrees, 57 or 58.77 degree angle. So this right here is going to be 58.77 degrees. Okay, so what's so bad about this? Well, what I'm going to show you right here is the problem if I have this angle right here, this side right here, and this side right here all the same, is that I can actually make both, this first triangle you see right here is acute, okay, or, okay, I can come over here and I can make an obtuse triangle. You can see I still have the same length of 10, I still got a 20 degree angle, okay, but this triangle right here is obtuse, okay, that's going to be an obtuse angle. And how I went about making that right there is, you can see right here, down here in this picture, okay, right down here is what I'm starting with. There's my acute triangle right there, and if I take this picture right here and I swing this around right here, I end up getting the same measurements. Okay, you can see that these things right here are still 20 degrees. Okay, you can still see that I have this length right here is 5.87. Okay, and I still have, okay, this length of GA. I don't have GA. Oh, there it is. GA's measurement is 3. It's still 3 in both of these triangles. So in both of these triangles, I have angle, side, side, angle, side, side. Okay, but you can obviously see that when I'm measuring angle A, they come out to be different lengths. So my question here is if I go about trying to find out angle A, okay, the biggest thing is A is going to be a different length right here, and this side GB is also going to be a different length. So as I come back here and look at this, I did this same case right up here, but I said, okay, if this is going to be an obtuse angle, the one thing you got to realize is when you got to this point right here, we got to remember that sine can be positive in two different quadrants. A sine can be positive right here in quadrant 1, okay, and sine could be positive right here in quadrant 2. Okay, if we found out that we had a 58-degree angle in quadrant 1, so this is 58 degrees right there in quadrant 1 from that one right there. In quadrant 2, what we're going to end up having is this 58-degree angle right here in quadrant 2, but instead of that being 58 degrees, the amount of the rotation that it's going to have from right here is going to be 180 minus the 58. So my angle that I come up with is actually 122, or 121. So I have two options right here for my angle C's. Okay, I found out that my angle C, as I rotated, was 121 in case 2 and 58 degrees in case 1. So what that's going to leave you to do right here is wondering which measurement do I work for angle C? Okay, is angle C going to be obtuse or is angle C going to be acute? Okay, so in this case, when you do have an angle with two sides, you're going to have to remember there's two different solutions that are possible. Okay, unless I tell you, which angle is going to be obtuse or which angle is going to be acute. And sometimes, you can see like this right here came up to 120. This right here is 20. Sometimes these two angles right here add to more than 180 degrees. And if they add up to more than 180 degrees, you know that the obtuse angle will not work. An example of that is if I would have came up with this angle right here, maybe have been instead of 20 degrees right there, maybe I would have had this angle right here as 55 degrees and then came up with this angle right over here to be 140 degrees, and you can obviously see those would add up to more. Okay, we'll talk more about that tomorrow. Okay, but I did want to make sure that you did know how to use that angle side rule. And for the last thing that I wanted to make sure is, do you not only know how to use the law of sines in triangles, but how about applications? Okay, so here we go on this problem right here. Okay, we're going to draw our picture right here. And it says, from a point on a level plane at the foot of a mountain. So we have our mountain, right here. A surveyor finds the elevation, to the peak of the mountain to be 20 degrees. So what you're going to look at right here is this guy right here is standing there. He looks up, and this angle of elevation to that highest point right there is going to be 20 degrees. So we know that angle of elevation is 20 degrees. Now this little guy right here, so the same little guy that I have right here, he's going to walk out here. I even make the sound effects when I'm talking to myself. All right, he walks out here, and when he does that, actually he was going to walk closer than that's supposed to be. This is going to be a 23-degree angle. All right, as I was looking at this, I think I got my numbers right here mixed up. I needed to start right here. This is my 20-degree angle right there. And then as this guy right here is going to walk closer, this angle that I have, right over here is not going to be 20, but 23. Hopefully you can see how this distance that he's walking right here, which I set up here was 3,465. Okay, how that part right there is going to make a bigger angle. Okay, what we want to find out is we want to estimate the height of the peak of the mountain to the nearest meter. Okay, so we want to estimate the height of the peak of the mountain, okay, to Mount Everest, I guess that's what it is, okay, to the nearest meter. Okay, so looking at what we have right over here, okay, there's a couple different methods you can go about finding this one. I'm going to actually use the law of sines, okay, on this one right here, okay, and when I use the law of sines, I'm going to use this triangle right here and using that law of sines. Okay, so pulling that triangle down here, I have this side right here is 3,465. I know this is 20, and this angle right over here is going to be 180 minus 23 because it's a linear pair to it. Okay, so I come up with 57 degrees, 157 degrees for this angle right here. Okay, what I'm trying to find, okay, on this one right here is if I can find out that length right there, I should be able to pull out this blue triangle right here, which had a 23-degree angle. And once I know x, okay, right here, I should be able to use, okay, the sine of 23 degrees is going to equal h over whatever x is going to be. Okay, so in this case right here, if I have x right there, in order to use the law of sines, I would need to have a set ratio. Okay, and if I'm looking up here right now, I don't see any set ratios, at least any set ratios I have at this point. So I'm going to take these two angles right here and add them together. I get 177 degrees, okay, and that's going to leave me with a 3-degree angle right up here. Okay, I now have a set ratio, okay, that I can use, okay, right here between the sine of 3 degrees over 3,465, and I can also come over here and do the ratio of the sine of 20 and put it over x. Okay, do my cross multiplying. Right here I get x times the sine of 3 degrees equals 3,465 times the sine of 20 degrees. And I can divide by the sine of 3. Okay, once I'm done there, that cancels out. Okay, type this into my calculator here. So I got 3,465 times that by sine of 20, and then divide it by the sine of 3. And I came up with a height of 22,644, and we'll say 8/10, and the label on this one is meters. Okay? All right. And now that right there is that don't be happy with it. It's not my final answer. That, and I'm not going to round this, I'm going to keep it in my calculator, okay, is just the length of x. So x right here is 22,644.08. I can now put, okay, this length, okay, right here, let me enlarge this here again, okay, into my calculator, cross multiply, and my height is going to equal the sine of 23 degrees. I'm going to multiply that out by the 22,644 degrees, and again, I'm not going to use the rounded part, I'm going to use the exact part of my calculator, okay, and I multiply that all out, and I come up with, finally, my last height right here that I have in blue of 8,847.75 meters. Okay, so this method right here I used was the law of sines method. Okay, there would have been another way you could have used it using right triangles. Okay, the methods that you would have used on that one would have been a big triangle right there, okay, and this smaller triangle right there. You just would have had to call this x right here, call this whole x right here at 3,465 plus x, and then do the systems of equations to find h. Okay? All right, hope that's went all right for you. The worksheet that I gave you, okay, this worksheet that I gave you, I already crossed off 1, 3, 5, 8 on the worksheet, so you'll see those problems are the only ones on the worksheet, okay, for tonight. So finish up on that worksheet, and hopefully you don't have any questions. If you do, we'll see if we can answer them on Tuesday. Hope you guys have a good day, and I'll see you tomorrow.